Okay, so we'll just start with 1 and we'll keep going. Alright? So, question 1 is basically I'm asking you to add up 1 plus 2 plus 3 plus 4 and so on up to 100. So let's see what we get there. So number 1, I want you to do 1 plus 2 plus 3 dot 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 up to 100. So clearly this is AP. AP with A equals 1, D equals 1, N equals 100. And so the total S100, N over 2, 2A plus N minus 1 times D, which is 5050. Easy peasy. Right. Number 2. Anne invests in a bond that pays 25 euros in the first year, 50 euros in the second year, 75 euros in the third year, and so on. How much does the bond pay out over 10 years? So it pays 25 in the first year, it pays 50 in the second, 75 in the third, and so on. Again, this is another AP, with A is 25, D is also 25, and N is 10 here because it's 10 years of payments. So this is S10, which is N over 2, 2A plus N minus 1 times D. Okay, let me just think here. So let me see, there's 11 25s, 4, 8, 12, 275, 2,000, 1,300 and something or other. 1,375, yeah. 1375 then.
Sorry.
Yeah. Yes. I shall call this one Stephen's Amazing Lesson with Practical Problems. Or I might just call it Tutorial on Sequence and Series Practical Problems. Or something like this, I don't know. First one. Actually, yeah, I'll think of some name at the end then. Okay, 3. The lessons are on the playlist. So this will be in order on the playlist. So it'll be the lesson after the previous tutorial.
Isn't there a bracket missing number 2?
Is there? I don't think so. It's fine, isn't it? Okay, next one. Number 3. Consider an arithmetic progression. Okay. The first, the second, and the sixth term are also geometric. And the first term is actually 2. So it's actually 2 plus D, 2 plus 5D. What is the D and the OR? So I'll give you an example just so you're clear of what's happening here. Like, consider this arithmetic sequence. Let's just say 2, 4, 6, 8, 10, 12. This is arithmetic, okay? If I pull out the first, the second, and the fourth term, I get 2, 4, 8. And this is geometric. Same thing is happening here. What I'm saying in the question is the first, second, and fifth of an arithmetic will make a geometric. So I know that these 3 are geometric now. So that means 2 plus D over 2 should be the same as 2 plus 5D over 2 plus D. D is not equal to minus 2. So if I cross multiply, what will I get? I'll get 4 plus 4D plus D squared equals 4 plus 10D. Yeah? Yeah. That gives me D squared minus 6D equals 0. So I get D minus 6 equals 0. Obviously D is not 0. So you get D is 6. Now remember, this division here represents what letter? R, yeah. So R is just 2 plus D over 2. So that's 4. If you were to sub that guy back in here. And there you go, D is 6 and R is 4. But that's question 3, isn't it? Yeah. Okay, can I scroll down? We still have a lot more to do. Yeah. Mo, you got it?
Yeah.
Got it? I'm going to scroll down. If you missed it, this screen is at the nearly 6-minute mark, 5:50. So if you need to get that, you can get it from the video afterwards. Okay, 4. The first, the second, and the 6th term. I picked the same numbers for 4 actually, again, for some reason. The first, the second, and the 6th term of the arithmetic progression are in geometric progression. The 11th term is 1. And this time find the first term. So the 11th term is 1. So you know that A plus 10D equals 1. And you also know that this is now geometric. So A plus D over A equals A plus 5D over A plus D. Cross multiplying gives me A squared plus 2AD plus D squared equals A squared plus 5AD. Squares cancel. So I'll get D squared minus 3AD equals 0. I'll divide by D because D can't be 0, so I get D minus 3A equals 0. Yeah? Now, I'll multiply this equation by 3, so I get 3A plus 30D equals 3, and just put that underneath. 30D plus 3A equals 3. I just carried that fella down there. I have these two equations to solve. Alright, so the best way to solve these two is just to add them together. So I get 31D equals 3. Yeah? So therefore, D equals 3 over 31, and I can put that back into, let's just say, put it back into here. Whoop. Okay, this goes back in there. A plus 30 over 31 equals 1. Yeah? 1 over 31. Yeah. So then A equals 1 over 31 then is the answer. Splendid. Okay. Number 5. Anyone needs time? 8:50. Okay. The sequence is in arithmetic progression. The first, second, and 11th term are geometric, and the first term is 1. 1 plus D, 1 plus 10D. What is the D and the OR? Yeah, okay, this is alright, isn't it? So the OR here is 1 plus D over 1, and that should equal 1 plus 10D over 1 plus D. So that means 1 plus 2D plus D squared should equal 1 plus 10D. So that means D squared minus 8D should equal 0. So that means D should equal 8. And you sub that back in there, and you get OR should equal 9. Yep. Okay, number 6. Okay. Right, number 6. A ball is dropped from a high cliff into the ocean. In the first second, it falls 5 meters. Then it falls 10 meters. Then it falls 15.
So 0, 5, 10.
Yeah, so the question is, how far has it traveled after 10 seconds? So it's basically 5 plus 10 plus 15, dot, 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 10 of these. It's AP, yeah. AP, A equals 5 and D equals 5. So S10 is N over 2, 2A plus N minus 1 D. Yeah? Huh? Oh, sorry, I put the 5 in my head because I was thinking of 10 over 2, yeah. 10. Right, so that's 5 times 10 plus 45. So that's 5 times 55? 275, thank you. 275. Seven. A frog hops 1 meter. He then hops half a meter. He then hops a quarter of a meter and so on. If he is sent to frog heaven and continues to do this forever, how far will he hop in total? This was changed. In the original version of this question, I had him sent to frog hell, but somebody suggested actually this might be a good thing for the frog, so it was changed to frog heaven. Right, 7 now. So it's a GP. It's 1 plus a half plus a quarter plus an eighth and so on. But it's an infinite GP. Okay, so what's the A here? It's 1, and what's the R? It's a half. So total is 2 meters. Number 8, we did this in class, but I'll just write the answer down. It's basically 2, or what was it? 1 plus, it starts with 1, doesn't it? Yeah, 1 plus 2 plus 4 plus 8, and all the way up, and there's 64 of these. So it's S64, which is, this is geometric, isn't it? Yeah. So that's A, 1 minus or n over 1 minus or. So the answer is 2 to the 64 minus 1. Okay, 9. And number 9 is also similar to something we had in class with the ball that drops from a meter, bounces back up and comes back down and so on. So what happens is the ball is dropped from a height 1. It falls a meter. It hits the ground and bounces up to 0.64 of a meter, but then it falls 0.64 again. 0.8. 0.8. And then it's 0.8 again, and then 0.64, and then 0.64. So we have to remember here, everyone forgets the ball. It's twice each number because it goes down and up, and then down and up. Yeah, so it's 1 plus 2 of all of these, 0.8 plus 0.64, etc., which is a GP. So that's 1 plus 2 times A over 1 minus or. So let's calculate that. That's 1 plus, that's 0.2, that's 10. Is that 8? Is that 9 meters? 9, okay. 10. I might need the calculator here for 10. Let's just see. Can I scroll down a little bit there? 10. Again, we did one like 10. At the start of the year, there was 1,433 billion barrels of oil. This year we consume 30.775, but then next year it increases by 2.5%, so we consume 31.544375 and so on. How long will this last? So the key here is that the total oil consumed has to equal the total available. We have 1443 available, and that must equal how much is consumed. Makes sense?
But do we know that the increase is?
It's the same 2.5% each year. Yeah, it's GP. So look, in the first year, it's 30.775, and then the next year it's 31.544375, and this continues. Now this is GP, and you can see it's GP if you take out your calculator and divide, and you perhaps won't be shocked to discover that the OR works out to be 1.00 or 1.025, which is not surprising because I actually tell you it's a 2.5% increase a year. So using our GP formula, what is it? A 775 1 minus R power n over 1 minus R. Oh jeepers, 1.025. Okay, now we'll have to do a bit of cross multiplying here. So it's 1433 times 1 minus 1.025 divided by 30.775. That will equal 1 minus 1.025. So I'll just put the calc. Did I leave out the n? Thank you. 1433 times 1 minus 1.025 divided by 30.775. So I'll just stick it as a decimal. Okay, so that is minus 1.16409, and that's supposed to equal 1 minus 1.025 n. I'll take this to the left and this one to the right. So I'll get 1.025 n equals 2.16409. So our problem has been reduced down to figuring out what power of n will make the left equal to the right. Now there is a quick way to do this using logs, but we haven't studied log yet. So we just want to estimate it. And we can do this with the calculator, okay? So, yeah, but we can be a little bit better than trial and error, okay? Let me show you. Practice our logical skills here, okay? So a little bit of logic right now. Let's imagine that the consumption per year didn't increase, okay? It stayed fixed at 30.775. How long will the oil last? It would last 1433 divided by 30.775. So it should last 46 years, okay? But we know that people consume more per year, so will the answer be more or less than? Less than, yeah, less than this, okay? Now, let's imagine at the very, very end, well, no, let's not do that. So it's 46 years, but we know it'll be less than 46. So maybe it'll be somewhere around 40 years, okay? We're not sure. What we'll do is we'll check values between, what will we say, between 30 and 40? 46 is obviously not going to be the answer, and 45 is not going to be the answer, and 44 is not going to be the answer. So we'll check somewhere in the 30s, okay? So let's just do mode table 1.025 power x. Now we'll start at 30, we'll finish at 40, and we'll go up in ones. And we're looking for the number, yeah?
You mean 46 or 47,
We're looking for 2.16.
This one is 51.
It's actually, it looks like it's very low 30s. It's somewhere between 31 and 32.
Our calculation.
Is Okay, watch again. Watch. Everybody watch. Mode table 1.025 power alpha x. Enter. Start 30. Enter. End 40. Enter. Step 1. Enter. Now, is 30 too big or too small? Too small. And is 31 too big or too small? Too small.
31.264.
Yeah, no, we're doing it the non... Yeah, no, I get it. I know this. Is 32 too big or too small? It's too big. So the answer is somewhere between 31 and 32. If you have to round the answer off,
31.
you'd say 31. Okay? Now, if you wanted to be even more precise, so we know the answer is between 31 and 32. I said it's between, what did I say, 31 and 32. So I'll start at 31 and finish at 32 and go up in 0.1s. So I can see 16. It's a little bit more than 31.2, but a little bit less than 31.3. It's about 31 and a quarter years. So I would tell someone it would last 31 years. So the N is 31 years of oil. Okay, 11 now. Oh, and by the way, I know some of you know about logs, and we will talk about logs later. But for those who know about logs, the calculator can tell you the exact answer by simply typing in log 1.025 2.16409. I know this, of course, I know this. This one is finishing at 22. Okay, 11 now. Scrolling down. LOG with a base. Now, let's see that calculator. Yeah. There you go. Now, look up. Guys, come on. The sides of a right angle triangle are in arithmetic progression. So here's a right angle triangle. And they're in arithmetic progression. So I would say A plus D, and A plus 2D. Now, you also are told that the total is 12. So in other words, S3 is 12. So that means A plus D plus A plus 2D, that should equal 12. Yeah? So that means 3A plus 3D, is it? Yeah, 3A plus 3D equals 12. So that means A plus D should equal 4. Right, well the problem here obviously is I need to make a second equation with A and D. What other equation could I form? The Pythagoras one, yeah. Because I can say A squared plus A plus D squared should equal A plus 2D squared. So let's see what we get here. I get A squared plus 2AD plus D squared equals A squared plus 4AD plus 4D squared. Right, what can I cancel? I can cancel one of the A squareds here with one of them here.
The 2AB and the 4AB, you'd have to...
What's wrong?
A plus D squared is 16. So you know A plus D.
Oh yeah, very good. Yeah. I could put in... Oh, but then I have this here. Yeah, no, that's very good. There is actually, I'll point it out at the end. There is another way to do this which is a little bit easier, but I just want to finish it with this way. So how many a squareds do I have? Just this guy here? Yeah, just that one. Okay, so he's done. How many ADs do I have? Minus 2 AD, isn't it? If I do this with this. And D squared?
3D squared.
Minus 3D squared. And that should equal? 0. Okay. Right, so we want to put these two equations together. What am I looking for? A or D? Or both? Both.
Any of them will do.
Right. It doesn't... Which one's easier? None of them. Okay.
Yeah.
A equals 4 minus D. We sub that in. 4 minus D squared minus 2. 4 minus D times D minus 3D squared equals 0. I get that? Yeah. 16 minus 8D plus D squared minus 8D plus 2D squared minus 3D squared equals 0. How many D squareds altogether? None. Is it?
No, you have
1 and 2 is 3. Cancels that. I get D is 1. Because I got 16 minus 16D equals 0.
Yeah.
And if D is 1, A has to be 3. So my sequences are 3, 4, and 5.
What's that?
26. Because this equation ends up being 16 equals 16D. Yep, that's why I picked it. Not easy, but a little easier. It's this a little bit easier if you label your sides like this instead. A minus D, A, and A plus D. I was told that this is a smidge easier because of the way things cancel. Yeah. But you didn't really, unless you saw this problem before, you had no reason to think that that would be the case at the beginning. So that's why I didn't want to do it like this. Okay, 12. Can I scroll down? Yeah, if you need the video, it's at 2746 there. 12. The sum of the first three terms, of and the third term of a sequence is
9.
what the heck am I saying here? The sum of the first term and the third term. Sorry, the sum of the first term and the third term of a geometric sequence
It's 9 times the
is 9 times the sum of the third term and the fifth term. Find OR. Do I tell you anything about A? No, but I don't need to, because as long as A is not 0, I can divide by A. So I get 1 plus OR squared equals 9. OR squared plus OR 4. 1 plus OR squared equals 9 OR squared plus 9 OR 4. 9 OR 4 plus 8 OR squared minus 1 equals 0. I hope you can see that this is actually what type of equation? Can you see it's actually quadratic? But what's the variable? It's not OR, it's OR squared. Is it quadratic with factors? Let's find out. Well, it has to be 1 and 1. And one of them has to be a plus and a minus. Oh, I think it's going to be 9 and 1, is it? 3 and 3? 9, maybe 9 and 1. 9 here and 1 here. So you get R squared equals minus 1, which is ridiculous. And you get R squared equals a ninth. So R is plus or minus 1 over 3.
Yeah.
Yeah.
did not really get that one.
This is at 30 minutes. 13. The number of people who click the second link in Google is 0.7 times the number of people who click the first link. For example, if 100 people click the first link, then 70 people will click the second link. This is true for most Google results. You know this yourself because as you move down the list, you're less likely to click it, and nobody goes to the second page. So the number of clicks for the third link is 70% that of the second. If 1,000 people search for maths help, then how many people click the first link? Okay, so let's call it X for the number of people who click the first link. How many click the second? It will be 0.7 X, because that's the second one. It's 0.7 of the first. How many people click the third one? Well, it'd be 0.7 multiplied the second one, which is, so it's 0.7 squared here. And this continues forever, practically. Not really, obviously, but practically it does. And we know what the total is for all these clicks. The total number of clicks is 1,000. So that means we have 1,000 should equal this infinite GP, which is A over 1 minus R. A over 1 minus R. So that means 1,000 equals X over 0.3. So X is 300. Okay. Oh my goodness, someone has their sat nav on. Who's that? Guys, I'm not continuing. This is someone that turns it off. You use sat nav to get to school? Right. 14. In a reactor, a neutron is fired at some uranium. After the neutron hits the uranium will split into 2 atoms and 3 more neutrons are freed. In addition, some energy E is released. So we have 1 free neutron, then 3 free neutrons, then 9 free neutrons. And this releases energy. It releases E energy, then 3E, and then 9E. And so in this example, the total energy released is 19E. And this process continues. How long until in total I get 29524E of energy? So this is GP. GP where the A is E and the R is 3. And I want to figure out how long until I get the number stated. So I want to figure out when will I get 29524E. Alright, so it's GP, didn't I say?
Yeah, 295.
So A 1 minus Rn over 1 minus R. So what's nice here is I didn't actually need the E's. That's a minus 2, isn't it? So 1 minus 3n equals minus 2 times 29524. So I get 1 plus 2 times 29524 equals 3n. So mode 1 plus 2 times 29524. Now 59049. Now wait just a second there. 59049. That's equal 3. Now, we have to estimate the n here. Let's see. 1, 2, 3, 4. So 4, 5. So it's going to be somewhere around 5, 6, 7, I think. So let's just do 3 power 5. No. Power 6. 3 power, it's all the way up to 9, is it?
Yeah.
Okay. No. 3 power 8. Huh? It's not 3 9? What is it then? It's higher. Is it 3 power 10? Oh, there we go. Yeah, okay. So it's a little higher than I thought. So 3 power 10 will equal 59049. So n is 10. Okay. Say again? Units? Oh, what was I asking for? How long would it take? It'll take 10 units of time. Okay, 15. John spends 100 euros. Then the person who gets this 100 euros will spend 90 of it. And then the person who gets that will spend 81, and so on. How much money was spent because John spent 100 euros? So this is infinite GP again. A over 1 minus R, which is 1,000. So 1,000 euros gets spent by John's initial 100 euros being spent. And the last one is something that we did in class. It's the bees. So you start off with one male bee, and then it came from one female bee, and the female bee had 2 parents, and we saw this sequence in class. When you write it down, the next one is 3. We discovered the Fibonacci sequence, where the next one is the sum of the previous 2. So this one here will be 5, 8, 13, 21, and right, isn't that right? Sorry. Next one is 5, isn't it? And the next one is 8. 13, 21, 34, and then 55, which is the one that we want. That's the 10th generation, 10th ancestor generation. Which one? Not yet. Soon, but not yet. Let me just check the attendance here. Mahmoud is HS1. Gafar? Yeah. Amjad? Yeah. Zara with no H. Yeah. Mo? Daniel? Sevi? Sabrina? Yeah. Sevi? Yeah, okay. Alfreda? Okay. You can speak, can't you? Yes. Arya? Chiadi? Yeah. Yupeng? Amna? Mariam? Down there. HS2? Michelle? There you are. Abir? Yep. Celine? Yeah. Sophia? Chidira? Thank you. Mohammed? Yep. Sabrina? Moza? Angela? Ahmad? And Zara with a H. Zara with a H is the Zara that is missing then. I just have a pen just to... Thank you. How are we doing for time? You didn't hear your name. What group are you in? And what is your name? Wait. Did I not say Mubarak? Well, I didn't mark you absent anyway, so maybe subconsciously knew you were there. Some attention was drawn to you perhaps today. Alright, 16 again. Guys, look up. 16 again, just to be clear, okay? So what happened was, you had, guys, look up. it was one male bee, and then we're told in the story that male bees come from only females with no fertilized eggs, but female bees come from a fertilized egg, so that's male and female. This male came from just one, and this one came from two. This one came from two, this one came from one, and this one came from two. So if you were looking at what's happening here, it's 1, 1, 2, 3, 5. We'll do one more. So this is male, female. This one was female, male, female. So this one is 1, 2, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. You notice what's happening is you add two numbers to get the next one. So like for example, the 3 and the 5 is what made the 8. So the next guy up should be then the 13 from 5 and 8, and so on. So the 55 was 21 and 34. Okay. 41. Okay, we have that. That's all the questions done. All right, so we'll wrap it up there now.
Okay.
Question about this?
Yeah.
No, sit down. I just did a full lesson on this. I did all the questions. You have the video for all of them, okay? I am confident in your abilities to figure this out yourself. I have so much trust and faith in you. No, it's not misplaced. You need to believe. You need to be confident. What? Yes. Now, what would we call the video? Discard the video? Why? Could I do it? Of course, but what's the reason?